In this lecture, we want to talk about the idea of a stack. Why do we need something called a stack in general? So let's say we want to calculate something like a plus b times c plus d, and the values of a, b, c, and d are follows. You see what I'm saying in this lecture is not only restricted to 8085. We want to understand the reason or give you the feel of the need of something called a stack. Otherwise, if you don't need something, you shouldn't learn it. So let's say this is our memory and this is our CPU, and for some reason we can't move our four values directly to the CPU. Maybe they are these A, B, C, and D are the result of some other operations, or maybe we don't have enough registers in the CPU to just contain all the values from the beginning. So the first thing that we need to do is to save all of them in the memory and then move them one by one in the CPU to execute this instruction or this operation. So we want to write a program to calculate a plus b times c plus d. And I'm using this pseudocode instead of the 8085 code to just tell you or emphasize on the fact that also we want to simplify things and emphasize on the fact that it's not restricted to 8085 only. By pseudocode, I mean something which is not real or not limited to one specific CPU. So the first thing that we want to do is to say move the value of 0 to, which is the value in the a variable, inside the address of 0x10. You see, this is equivalent to me saying that we want to move the value of 2 in the address of 0x10. They both have the same meaning, but this is simpler for both of us to write them in this format. Of course, you could convert them in the 8085 code if you want. To convert this is that you should say this. You know, to move values immediately to the memory location, you say move I m and the value, which in this example is 02. But you know m is a memory cell that the HL register pair is pointing to, so you need to first move the address of the memory cell that you want to be the destination of the 02 value inside the HL register pair. For that purpose, you say LXI, and then uh, of course you say H, and then the value which would be the value of 0010. This 0010 would cause the value of 0010 to go in the HL register pair. Now that you have this value, which would be 16 bits, you see we are assuming that our addresses are 16 bits just in the 8085 microprocessor. So you move this value to the HL register pair, and then this instruction would cause the moving of 02 inside the memory cell that HL is pointing to, which currently HL is pointing to the 10 memory location. And after this, you would say in X and H. This would cause the HL register pair to be incremented by 1, the HL register pair. And then you see if you wanted to increment just one register, you'd use in C, I think, but here you say in X H, which would increase the value of HL register pair, and then after that you say move I M, and this time 05. So this would cause the moving of 02 inside the memory location 2, and this here would cause the 05 inside the memory location 11. Here 10 and here was 11 because we incremented the HL register pair. But as I said, we are not doing that. We want to use our pseudocode to just make things simpler, because our goal is not to write a program, but is to prove a point of why we need something called a stack. This is just normally we are doing to move values or execute these operations. So after that, we say move this time 0x11, and or it could be decimal or hexadecimal, and this time 05. So we have moved the value of the a variable inside the 10 memory address, and then the b variable inside the 11. After that, we say move 0x12, and we move the value of 06, which would be the variable, the content of the variable c. And after that, we say move now the value the address of 13 would be the destination or the address of our destination memory cell, and 09 would be the contents of the D variable. So right now, because of the execution of all of these four instructions, we would have the value of 02, 05, 06, and 09 in these consecutive memory cells. So now we want to calculate the A plus B. But in order to calculate A plus B, first we need to move them inside the A and B register. So first, I say move the value in the 10 memory cell inside the A register, and then move the value of 11 memory cell inside the B register. The execution of these two would cause the contents of 02 to be inside the A register and 05 to be in the B register. And then we say, let's say just add, or add B if you want to do the instruction based on 8085. This would cause A to be equal to A plus B, or the addition would happen and the result would be inside the A register. So right now we would have 07 or 02 would be overwritten by the addition of both A and B, which would be 07. Before we calculate this, because we don't have many registers, we again need to use the same A and B register. First, we need to save this in some part in the memory location so that we bring it later when we need it. So what would we do here? Again, we say move A and 0x14. Let's say this instruction would cause the value of A to go inside the location of 0x14. Again, in the 8085, you could have done the same thing by saying move A and M. Of course, M is what the HL register pair is pointing to, so you needed to say LXI, H, and here the double byte would be 0014. And you know again that this in the memory, if you wanted to write this instruction in the memory, we because of the Indianness, the lower byte should go to the lower byte and so on. So we have saved the value of the A in a memory cell. The reason is because you want to empty the A register so that you could use it for execution the operation of C plus D. So your goal now is to move the value inside the, also let's say that now we have 07 in here. Now you want to move the value of the 12 register inside the A, 12 memory cell inside the A. So you say move 12 inside the A register and move 0x13 inside the B register. This would cause the contents of the 12 memory cell, which is 06, to go inside the A register. So 07 would be overwritten by the value of 06, and 09 would overwrite the already present value inside the B register, which was 05. So now you have 09 in the B register. Then you need to add both of them again. So one more time, you use the same addition, which would cause the A to be loaded or to be overwritten with the A plus B. So now 09 plus 06 would be equal to 15. I just write it in decimal, so I don't. We shouldn't wipe out the value of the B register. Only the A register would be overwritten, and we would have 15 here. Now, because you don't need now to save the A register, because you want to multiply the value of the C plus D, which is already in the A register, and A plus B, which you saved it in the memory cell of 14. So what you do instead, you say now move the value in the 14 memory cell inside the B register. So this would cause the value of the 14 to go inside the B register, which would be 07. Now at the end, you just say, let's say you have an instruction called mul, which would do the multiplication. So 7 times 15, whatever that is, which would be, well, 105, I think. And this value would override the value inside the A register, which you would have 105. And let's say as the last instruction, you would say now move the value of the A in the 0x15, which would cause the 105 to be written inside the 15 memory cell. So we just wrote our program with all of these codes that you see here. We have maybe two problems. One of them is that too many lines of codes have been used for that, or more importantly, the programmer has a hard job to do all of these because of all of these addresses. You as the programmer, you need to take care of all of the addresses, which address is empty, which is not. Maybe even I made a mistake here by just overwriting one of the memory cell twice, and one single mistake could cause the destruction of your program, or maybe having some other result than having the value of 105 inside the 15 memory cell here. So you need to have something else which could ease the job of the programmer, that you don't require the programmer to just take care of all the memory cells to understand which memory cells are empty, which have been overwritten, which have the valid data, and so on. Here comes the concept of the stack. So I want to prove to you how by something called a stack we could write the programmer or ease the job of the programmer so much more in the next lecture.